So in our second video on recursion here, we are going to print out an array. Simple enough. Normally we have done this with a for loop. So as an example here, I'll just create this array. We're going to initialize it with 5 different numbers, and we're just going to print them out with a for loop so you can see. So I want to start my for loop with an integer set to 0. And we're going to say while it's less than 5 because that's the size of it. I++. And we're just going to simply C out to the terminal. So this is in the past how we've iteratively printed out an array. So we just go along the line and just print them each out. And just let's run it just so you can see that that actually works. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Perfect. So I'm going to show you how to convert this to something recursive. Now, normally for a loop like this, you wouldn't run a recursive algorithm on it, but I just want to show you that most things that do iterate, you can also run them as a recursive algorithm. So how we would develop this as a recursive algorithm, again, we always start with the base case. So in this example, we want to say if our array is the size of 1, that's when we're going to print it. So we'll say if size is equal to 1, because we want to print out the first value first. So we'll say cout r size minus 1. And again, the reason I'm doing size minus 1 is because if it's printing out an array the size of 1, that's always going to be position 0. So again, arrays are always indexed starting at 0, so that's why I'm doing 1 minus 1. So array 0 would be the first item in that array. So that's our base case. And then our subproblems, again, they need to first of all make a subproblem. So usually that's going to be with size minus 1 because that's going to decrease the problem. It's going to make a smaller subproblem. So we would call the function on itself. We'd pass it that same array because the array never changes, stays the same. We just keep passing it to itself, and we would just pass it size minus 1. And so this will keep going till it gets smaller and smaller, reaching 1 finally. And then after it hits that 1, it will unwind, is what it's called, coming back out into this else statement, and then we'll have it print out itself. Perfect. And so we should be finished here. Let's go ahead and run this one just to make sure it works. So in my problem, again, just so you can see, I have initialized this array, has 5 numbers in it, 0 through 4, and then we're just going to print it out in that function. So I've saved it. Let's go ahead and build and run. And as you can see here in the terminal, it worked as expected. Just printed out each number of the array. So just an overview again of how this recursive algorithm works. We defined our base case. So when we reach the very first item of the array, that's when we'll print it. If it's not the first item of the array, it will continue to make subproblems here by passing it to itself. So it's always going to take whatever size it is and subtract that by 1 until it finally reaches 1. And then after it hits that, it will print itself out, and eventually it will do the exact same as an iterative function would do. Now you may be thinking to yourself, why would I ever recurse across an array just to print out the values? And honestly, you wouldn't. This is just kind of showing your chops that you do know how to run a recursive algorithm more than anything. You'll often see recursion in sorting algorithms. So imagine you got a jumbled array full of numbers that was 100 numbers long, and you wanted to sort that out. You'll often see recursion in sorting algorithms or in search algorithms. So binary search is a fantastically efficient algorithm that uses recursion. You can think of it as it splits the problem set in half each time, and that is oftentimes where you'll see recursion. So the purpose of this lesson was just so you could see that functions don't always have to be set in an iterative manner, that they can also be solved in unique ways by calling subproblems of the original problem. With recursion, though they oftentimes look more elegant, as you see here, these functions, they're just very simple, they do come with a cost. Every time these functions call themselves on the computer, it needs to reserve space to go that one level deeper. And if you create a function that doesn't have a base case that's effective, oftentimes you can do what's called blowing your stack or crashing your stack, stack overflow, and that's just basically the program has taken up more space than the computer can allot for it, and it crashes the program. So that's obviously a problem, and you don't want that to happen to your program, so just be aware of that cost. Often too, recursion isn't as fast as iteration in these specific instances that I've shown you. Like a dynamic programming example or an iterative example would have been faster for these problems that we discussed today. But I just want you to be aware of recursion and get an early look at how recursive algorithms work. For deeper learning on C++, visit us at makethingswithcpp.com and be sure to like and subscribe.